So in this question here, we've got a pulley system and we want to work out the force and magnitude exerted onto the pulley system by the tension in the strings and the mass of the blocks as it's moving down. So the answer to this question I'm going to give in terms of G for gravity. If we call G equals 9.81 meters per second squared, I'm just going to leave everything in terms of G and then we can work out that later if you wish. So with these questions, to work out what any magnitude or direction of any forces is, certainly the magnitude, we need to work out what's going on with the pulley system. So we'll isolate each force at Y and X using force equals mass times acceleration. So at Y, what's going on at Y? So the forces will be gravity pulling down on the block, so that's 3 mg. And the tension in the string will be going away from that and away from the direction of travel, so that's minus T. And we set that to mass times acceleration. Well, the mass is 3m, so it's 3ma. So then we need to look at what's going on at X. So at X, this question we're also assuming that this table or this surface here is smooth. So all we've got here now, that tension will equal 2 times ma. So that's what we can assume there. Okay, so now what we can do is we can try and solve for T by getting A first. That looks like the easiest way to go from here. So I'm going to do that way. You could do the other way, it's up to you, but I would have to multiply things out to try and get the same here. So let's just add them together. So then I've got 5ma equals 3mg. So the t's will cancel out. Then I can get A on its own. So A equals 3mg over 5m. So the m's will cancel out and A will be 3g over 5. So that's my acceleration. Now I've got acceleration, I can plug it into here and get an approximate value for my t. So using t equals 2ma, t would equal 2m times acceleration, which is 3g over 5. In which case t equals 6mg over 5. So that's my tension in the strings, but we haven't quite got there yet. We need to work on what's the magnitude and direction of the forces. So this tension here will help me. Acceleration was just a bonus just to get us to find tension. So the magnitude and direction of the forces. Well, the direction of the forces will be evenly split between these two sides of this right angle. So if that's a right angle, the magnitude of my forces is going to be in this direction, going 45 degrees and 45 degrees. So that's the direction, so that takes care of that. Now we need to work out the magnitude. Now there's two ways we can do this. First of all, what we could do is, as we've got a direction going in here, we could use the formula, which is the forces would equal the square root of the two tensions. So this tension and this tension. So t squared plus t squared. That will be what my forces are, and they will be shared amongst the two. So now the magnitude of my forces would equal square root t squared plus t squared. So that's 2t squared basically. And then that equals square root of 2 times, now what's this squared? So I'd have 36 m squared g squared over 25. That's just it for it to have, so we can see what it actually looks like. But what I could do is, as this is all in terms of squared, using my rule with surds, I could take this out of here, out of the square root, and leave it as in this form, and leave the square root of 2 multiplied by it. So in which case, my force acted on this pulley by these two sides of the string would be root 2, and then that would come out of this surd to just leave me with that. So that would be times 6 mg over 5. So So that would be one way of working out my forces. The other way is if I was to draw a line along here and make a right angle where it joins the direction of the forces. So if I just draw that line there, and then I've got two right angles here, I've then got two right angled triangles. So 45 degree, 90 degrees. So this will also be 45. And this one here also 45. Now to work out what my forces are, what I need to do is resolve for this force here. So I've got that force here, let's call it R. Now to find that, I know what this side is, which would be my hypotenuse. That's just my tension. So that will be equal to my tension. So now I can find R by using SomeSums. So on this side, so let's call this side R1, this side R2. Of course R1 equals R2 because it's by the triangle inequality, it's the same length. So the length of these sides will equal my forces. So R1, so let's work out what's going on here. So if I use cosine, because it's adjacent, cosine of 45 equals R1 over T, adjacent over hypotenuse, over T. So then to get R1 isolated, I've got R1 equals T cosine 45. Cosine of 45 is root 2 over 2. So that equals T root 2 over 2. Now I know what T is. T is 6 mg over 5. So then that equals 6 root 2 mg over 5. And it's also divided by 2 as well. So I know I need to have 2 times 5 on my denominator. So then my R1 would equal 3 over 5 mg root 2. Let's write it in a different way with a third at the back. But then I've got 2 of these. So R1 equals R2. So this force here, R, is equal to the sum of R1 plus R2. So R equals R1 plus R2. So then I've got this one here, 3 root 2 mg over 5 times 2, which would then simply give me 6 mg root 2 over 5, which is exactly the same as what we had here. So that's 2 different ways of calculating my force exerted onto the pulley by the strings and the weight of the system. Okay.